We are back with more product rule examples. Here on the last one we did, we had something that could have just been done with power rule after we multiplied out. This one we're going to do a little differently, and I want to go ahead and write the rule a little differently too. Instead of with U's and V's, I'm going to write it with function notation. All right, if I have a product of two functions, to find the derivative, I'm going to take the first function times the derivative of the second, plus, and then flip-flop it, the second times the derivative of the first. The order really doesn't matter there because addition and multiplication, both commutative. So let's suppose that I have, let's say, natural log of x times square root of, well, let's not do square root. Let's do times, yeah, let's do it. Let's do square root. There we go. All right, first thing I like to do is, first of all, let me just point out the biggest concern here is make sure you recognize you have a product. That can be the hardest thing about product rule is recognizing that it's time to use it. So I have a product of two things that standing alone would be their own function. So there we have it. All right, so I have my product, I have established what two things are being multiplied by. I like to use those parentheses to help me recognize that. So derivative of my function x here, I'm going to do the first as is times derivative of the second. And the derivative of square root of x is 1 over 2 root x. All right, plus the second. That means the second of these two factors I'm multiplying, as is, times the derivative of the first. What's the derivative of the natural log of x? 1 over x. So again, how you write your final answer really depends on what you're asked for. If you're doing a circuit, you might need to get it in the right form to be able to find the next answer. If you are doing an FRQ, you might not need to simplify, you might need to plug something in. And if you're doing a multiple choice, then basically whichever answer matches your answer is where it's at. But that is a perfectly fine answer. That is the answer. We could get a common denominator if we wanted to, but I think we'll stop there for now. Thanks for watching.